just a short video to show you how do we relate percentage changes to logarithms and how we derive basically those interpretations, okay? So let's start with our typical log level regression. So as you can see here, our outcome is in a logarithm, our covariate, it's not, okay? And basically what we want to try to understand is what happens to the outcome y when we change x by 1 unit, okay? This gets a little bit harder because we now have a logarithm, but we'll see that we can actually derive something that makes sense just using a little bit of math, okay? So let's start just thinking about two individuals. Imagine that we have individual 1 who has an outcome of y1 and a covariate of value x1. It doesn't really matter what those levels are. And then we have also a second individual, individual 2, who's going to have an outcome y2, which again, we don't know what it is. And a covariate though, that is going to be just 1 unit larger than x1, than, sorry, individual 1, okay? So his covariate is going to be x1 plus 1, okay? So now basically what we want to try to understand is what happens when we increase x by 1, okay? How does y change, okay? As I just mentioned, this is not going to be as straightforward as a typical regression because we have the logarithms, but we will be able to derive something that is useful, okay? So let's start by writing down the equations for each of these individuals. So let's start with individual 2. So we have that for individual 2, the log of y2, it's going to be equals to beta naught plus beta 1 times their covariate, which is x1 plus 1. And then we have the same regression, but for individual 1, okay? So we'll have log y1 equals to beta naught plus beta 1 times x1, okay? And again, because we want to get at the basically the difference in the outcomes, we are going to subtract these two equations right here, okay? So on the left-hand side, if we subtract these two things, we will just get the difference of the two logarithms. So it will be the log of y2 minus the log of y1. And on the right-hand side, you can easily see that those beta naughts cancel themselves out. Beta naught minus beta naught, right? And also beta 1 times x1 is going to cancel itself out. So this is not going to no longer be there, and this is not going to be there either, okay? So all that survives on the right hand side is beta 1, okay? So we have something now that again is a little bit simpler, but we'll need to keep working at it. So if you remember just basic algebra, the difference in two logarithms is just the logarithm of the ratio. So we can write this left hand side as the log of y2 over y1, and this is equal to beta 1 hat, okay? So again, we've simplified this, but we still need to do a little bit more work. Let's go to just a blank page and start where we left. So it's y2 over y1 equals to beta 1 hat. So now what I'm going to do to show you that this is actually a percentage change is I'm just going to do a little trick of adding 0, okay? What do I mean by that? Inside the logarithm, I am just going to subtract y1 over y1, and I'm going to add that same amount right here. So as you can see, I'm not really doing anything because I'm adding 0. This does not change at all this equation. But this does allow me to show you how this is actually a percentage change. So if you see this right here, this term is basically y2 over y minus y1 over y1. And that is what we know as a percentage change, right? This is delta y over y, okay? And this, as you can see here, this is just 1, okay? So let's just go back to our equation. We can see that we have log of delta y over y1 plus 1 equals to beta 1 hat, okay? So now all we have left is just get rid of that logarithm, and for that I just exponentiate both sides. So I raise everything e to the power of both sides. And we will have that delta y over y1 is equal to e to the power of beta 1 minus 1. And that is exactly what we saw in class. And this will basically entail a percentage change. We multiply by 100 just because remember that delta y over y, it's going to give us basically a proportion. And we need to put that in a scale of like in 100%, right? So multiply that by 100, okay? So that's basically how we get there. How do we go from this exact approximation to this exact association to the approximation that we saw about just multiplying beta 1 by 100? It's also very easy if you remember probably from calculus. You might remember that when x is very small, basically trending towards 0, we can actually approximate the logarithm of 1 plus x to x, okay? So if you remember from the last slide, we had that the logarithm of 1 plus delta y over y1, we can approximate it to delta y over y1 when this is basically trending towards 0 or it's very small. Again, rule of thumb, you can think that beta 1 needs to be equal or less than 0.1, and then we can just do that approximation, okay? So that's the idea. That's where this comes from. Hopefully it was useful and you understand a little bit more the math behind it, okay? But if you have any questions, just feel free to reach out and I'll see you in class.